Continuing on, identifying even and odd functions, this time without a graph. So we're just going to work this out mathematically. And if you're thinking to yourself, well, I have a graphing calculator, can I just graph all of these? And the answer is yes. But I'm going to show you how looking at it mathematically, you can actually do it quicker than you can typing them into the graph. You got to trust me. So we do one of two tests. We check to see if it's even. We check to see if it's odd. And that's based off of the highest degree. And that's why we spend so much time identifying even and odd degree functions. So if we look at x to the fourth plus x squared minus 1, our key degree here, our highest one is the 4. And since 4 is even, this answer is either going to be it's an even function or it's neither. Right? So I don't have to check to see if it's odd because it starts with x to the fourth. Okay, that's the first one. That's a big hint. Okay, so if it's an even function, this has to be true. F of negative x needs to equal f of x. And before you tune out and say, Ellis, that's impossible, I don't know what you're talking about anymore, just, it's okay. We're going to get it, okay? So f of negative x, all that means is anywhere I see x, I'm going to replace it with negative x. So let's put that up here. So f negative x is going to equal, so x to the fourth will become negative x to the fourth plus negative x squared minus 1. Okay, and then we just need to simplify this. So I need to know what is negative x to the fourth power, and just in case you forgot, let's actually do this separately. Don't worry, I'll go back to the original problem. So negative x to the fourth power. If we break that down, what that is negative x times negative x times negative x times negative x. Okie dokie. So if I were to multiply this, negative x times negative x, remember a negative times a negative is a positive, and then x times x is x squared. Okay. I can do the same thing over here and get the same answer. So you notice all of our negative signs have gone away. And then our last step, x squared times x squared is x to the fourth power. So negative x to the fourth power is equivalent to x to the fourth power. And that's true for any even degree. So negative x to any even power, you just drop the negative sign. Okay, so negative x to the fourth is just x to the fourth. Negative x squared is just x squared. Okay, what about though, what if it's not even? What if we had negative x to the third power, and we're going to need that for our second problem, so we might as well do it now while we have this page open. So this will be negative x times negative x times negative x. So it starts off the same way. These first two, we multiply them together, that gives us x squared. But then we just bring down this last x. So now we have a positive times a negative, and a positive times a negative, hopefully remember, is a negative, and then x squared times x is x to the third. So negative x to the third power is equal to negative x to the third power. Notice we dropped the parentheses. So we're saying whatever x is, right, we're going to end up with a negative value at the end. Okay? So if it's an odd degree, negative x to an odd power is just the negative version. Okay, so evens, you drop the negative sign. Odds, keep the negative sign. Not too bad, hopefully. If not, write it down, because that's always the rule. You don't even have to understand it. It's just the way it is. Okay, so going back to the problem. So I can rewrite this negative x fourth. It's just negative x fourth plus, wait, I shouldn't have put negative. Sorry, my bad. So x to the fourth, negative x squared is just x squared, minus 1 is minus 1. Okay, and then we compare that to the original. Remember we said f of negative x should equal f of x if it's an even function. Is that true? Does this equal what we started with? And yes, it does. It's exactly the same. So we can say that this is an even function. Okay, that's our check. So we take the whole function, make all of our x's negative, simplify it, see if it looks the same as our original. Okay. The second part of these is the number of turns. I don't know why it says that. Let's replace this with maximum number of turning points. Okay, here's the thing. So we could count the number of turning points if we had it graphed. Remember we said we don't want to graph it today. So instead of saying exactly how many there are, which we cannot figure out easily, right? You either need to make a table or you have to graph it. Either way, that's more work than we want to do. So all I want to know is what is the maximum number of turning points? And remember we said our formula for that was just n minus 1, where n is the highest degree. And since our highest degree is 4, we would say 4 minus 1 is 3, that this has 3 potential turning points. So we could graph this. It might have 3 turning points, it might have 2, it might have 1, right? But we know it cannot have more than 3 turning points. That's all we're looking for. So just n minus 1, where n is the highest degree. Okay, so odd functions. This one's a little bit more difficult because this one we want to know, does f of negative x equal negative f of x? Right, so that's 2 separate things we need to figure out. So we start with f of negative x, just like we did last time. So f of negative x, and then this is our new function we're looking at. So we'd say negative x to the 3rd power minus 7 times negative x. And then we simplify it. So we learned over here on the second page that negative x to the 3rd power is going to simplify to just negative x to the 3rd power, no parentheses. And then negative 7 times negative x, we just multiply those together. Negative times negative is positive. 7 times x is just 7x. So that's f of negative x. Negative x to the 3rd power plus 7x. Okay? And then I want to know what is negative f of x. This one's a little bit different. I don't think we've done this year, but it's a lot easier than you could ever imagine. So negative f of x, all we do is we take the original function and we multiply it by negative 1. Or more simply, we put a negative on the outside. So negative x to the 3rd minus 7x. So that's all negative f of x means, is you put a negative on the outside, which essentially just changes every sign along the way. So this would become negative x to the 3rd. Negative times negative becomes positive, and that's it. Okay, so now I'm comparing negative f of x to f of negative x. Are those the same values? Yes, they are. So this x to the 3rd minus 7x is an odd function. Okay, and if you graphed it, you would see that it would go through the origin, and if you flipped it 180 degrees, it would look exactly the same. As far as turning points, n minus 1, our highest degree is 3, so this has a maximum of 2 turning points. All right, not too bad, not too bad. All right, last one, neither. This means that this rule is not going to work. I don't even think we need to. We might as well do this example. Yeah. Actually, instead of doing the example 1, because we already know what that answer is going to be, let's just work one out. Let's do number 1. Why not? Free answers. Who doesn't like free answers? So let's see. F of x, 9x to the 3rd power minus 8x squared plus 18. So I look at my degree. My highest degree I see is 3, and that's an odd number degree. So I know this is either an odd function or it's neither. So I'm not even going to worry about this even test because this cannot be an even function. So I'm just going to look at the odd. So does f of negative x equal negative f of x? Let's find out. So f of negative x, so that would be, let's see, 9 times negative x to the third power minus, minus 8 to the negative x squared plus 18. Okay, then we simplify this best we can. This is going to be, oops. So I know this is 9, that just comes down. Negative x to the third power, remember we said that's going to be negative, and then we can bring this x to the third power. Okay, so let's see. Negative x squared is going to become x squared, and then negative 8 times x squared is negative 8x squared, and then plus 18. Okay, so you don't mess with the coefficients as far as the numbers. All we look at is what happened to the signs. That's our the big look for here is what happens to the signs as we do f of negative x and negative f of x. All right, so negative f of x, so it's just the negative version of the entire thing. So negative x to the third minus 8x squared plus 18. So I'm just going to go through, I'm going to flip all my signs. So negative, negative 9x to the third plus, right, negative and a negative becomes plus 8x squared, and then negative plus 18 becomes negative 18. So there's my negative f of x. And then I compare the two. Are these two answers that I got exactly the same? And you would say, no, not even close. We got different sign on the x squared. We got different sign on the constant. So this is neither. As far as our number of turning points, since our highest degree was 3, 3 minus 1 is 2. So this would have 2, and this should again say maximum number of turning points. Okay, so it's a little bit of work at first. At some point, hopefully, as you're going through these, you realize a pattern that's happening, and eventually get to a point where you don't have to do all this work. You can just look at it. You can recognize what you're actually checking for, and you can come up with the answer in your head. I don't want to give away how to do that because then you won't learn anything. But I will tell you, it is possible to do all these questions without having to write all this down and without having to put in a graphing calculator. Okay? But work them out at first so you can see what's happening. You will see the pattern if you do enough of these. Okay, once you recognize the trick, leave a comment down below along with your name, and I'll maybe give you extra points because I'll be so proud of you. You're so smart. Okay, bye.